Um unser Leben in Zukunft einfacher zu machen, sollen schwierige oder gefährliche Aufgaben von Robotern übernommen werden. Zum Laufen oder Objekte zum Greifen, sich in einer unbekannten Umgebung zurechtzufinden, ist für uns Menschen meistens relativ einfach. Das Ganze einem Roboter beizubringen, ist für die Wissenschaftlerinnen und Wissenschaftler sehr schwierig. Der Linus und der Vedant vom Lehrstuhl für Cyber Physical Systems beschäftigen sich genau mit dem. Und da gehen wir jetzt hin. Hi Linus. So you're a Ph.D. student at the Chair of Cyber Physical Systems here.
Exactly.
And your research is on autonomous navigation.
Exactly.
What is that?
Well, autonomous navigation is the ability to move from one point to another. Just like we are human, we could move from one point to another, both known and unknown environment. We can give the pictorial view of how the environment looks like. We can give the description of our location in the environment and return to our home effortlessly. This is a complex task that is very difficult to implement in a robotic system.
So what is the main focus of your work?
So to achieve autonomous navigation in robotics, we have three main problems that we have to solve. And one of them is, where am I? That is, in robotics, is called localization. Where am I going? That is called mapping, that is map of the environment. And how do I get there is what is called path planning.
Can you show me some demonstrations?
Yeah, sure. As a standard approach, here you see the robot. Here is in here, the robot, our robot here. And then we have the laser scanner, which scans the environment to know how it looks like. Just like you use your eye to scan this place, you can give description of the anything you see within this environment. For example, if I want the robot to go to the kitchen, I'll just select 11 here. And then if I press enter, it plans a path.
Can you actually implement this in real life?
Yes, of course, we've already developed a prototype for testing all the simulation approaches. So we have the robot here, and then we have the hoverboard wheel that helps the robot to move. And then we have RGB cameras that act as the eye for the robot to see the environment. And then we have the RP LiDAR scanner. It scans the environment to see where there is obstacle in the environment. And then we have our microcomputer here, which processes all the information and gives us the detail we need.
So if I want a cup of coffee, the robot can navigate to the kitchen autonomously, but can it grab the cup?
Obviously, yes. We are working on that. My colleague Vedant is working on data manipulation, and then we plan to integrate a robotic arm that helps the robots to achieve that.
Hi Vedant. So Linus showed us how the robot can navigate to the kitchen autonomously. How could it grab a cup of coffee?
So autonomous navigation only includes navigating part. If you want to grasp a cup of coffee, you need a hand, robot hand, and we call it a manipulator. And this is where my research comes into picture. How can you grasp different objects based on its shape or properties like hardness or thickness of the object or how soft it is. So when it comes to grasping, we have two different ways. One is teleoperation and another is the robot grasp on its own. So this is what we use in training the robots, that is teleoperation. So whatever operation I perform, similar operation is performed by the robot.
So what kind of impact do you think your research will have on everyday life?
Here we focus on things that you see in your everyday life around you, starting from autonomous cars to robotic surgeries, to industries where humans work in collaboration with the robots and humans feel safe. In 2020, when there was coronavirus, everything was shut down. No humans can go to industries to work. And there comes robots that help you run your industries and run your economy. In cyber physical systems, we work on real world application that impacts majority of population.
Wir Menschen streben danach, zum Neuland erforschen und Unbekanntes zu verstehen. Genau das unterscheidet uns unter anderem von den Maschinen. Das Ziel von Forschern wie dem Linus und dem Vedant ist es, Eigenschaften wie diese Neugierde oder Selbstständigkeit den Robotern zu vermitteln. Somit sollen diese zukünftig komplexe Aufgaben autonom lösen.
Montanuniversität Leoben. Alles außergewöhnlich.